I've been in networking for over a decade and decided to make some content to try to help others understand this industry. So let's talk about the hexadecimal number system. It is a base 16 number system, which means there are 16 unique characters, and the first 10 are the exact same as decimal. So we get 0 through 9. But that only gives us 10 unique, and we need 16 unique characters for hexadecimal. So we have to go to another kind of structured character system that we have, which is familiar. So we go to the alphabet. So after we get to 9, we extend into the letters and go A, B, C, D, E, F. So that gives us our 16 unique characters. So when we're counting, we start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, just like in decimal. But after 9 becomes A, then B, C, D, E, F. Once we get to F, just like any other number system, that place falls back to the very beginning, which would be 0, and the position to the left increments by 1. So now we get 1, 0, then 1, 1, 1, 2. I want to be very careful here. This is not 10, 11, 12, 13. This is 1, 0, 1, 1, 1, 2, 1, 3. Because we're in base 16, this is not the same as decimal 10. So 10, 11, and 12, those are all decimal numbers. These are hexadecimal. It's a different value because our base is 16. So once we get to 1F, then the 1 rolls over to a 2, and the F starts back over at 0. So this pattern continues on. And then when we get to 9F, the interesting thing here is it's going to be kind of habit to roll the 9 to a 0 because that's what we're used to. But instead, we have more characters after the 9. So the 9 becomes an A, and then the F rolls back over to 0. So we go A0, then A1, A2, A3, all the way through to AF. After that, we get to the B's. So it would be B0, B1, then C0, C1, all the way through. Once we get all the way to F in the second place, we'd count F0 through 9, FA, FB, FC, FD, FE, FF. And at that point, once we have FF, now we have reached the max value for each of those positions. Then we finally roll over and you get 100. Again, this is not 100. That's a base 10 number. This is 100 because we're base 16. So let's look at the place values for hexadecimal. So the position all the way to the right is going to be 16 to the power of 0. Next over that is 16 to the first, 16 to the power of 2, 16 to the power of 3. Just like any other number system, our base here is 16. If some of this doesn't look very familiar, please check out the binary video where I kind of went a little bit more into detail about this. So let's calculate the place values here. So the position all the way to the right is going to be the 1's place, and then we have the 16's place, then we have the 256 place, and then the 4096 place. So this escalates much quicker because we have 16 unique values. So let's do a quick conversion from decimal to hex. Again, if this seems a little bit difficult to follow, please review the binary video where the principles of this kind of they get addressed in a little more detail there. So we'll take the decimal number 3166 and convert that to a hexadecimal character. So the first thing we need to do is figure out how many places are we going to need. Well, 4096 is larger than 3166, so we don't need that place at all. So we know that this is going to be a 3-digit hexadecimal value. Now what we have to figure out is how many 256s do we have inside that 3166? Well, to do that, we divide 3166 by 256. That gives us a number of 12.367, on and on. We're not too worried about the decimal value here, like the fractional value, I should say. We just want the whole numbers here. So we know that there are 12 256s inside of the decimal number 3166. So we check our conversion here, and the decimal 12 is represented by a hexadecimal character of C. So that's what we put in the 256 places because we have C 256s. So there we have a C in the 256 place. So the next thing is we have to figure out how much of that 3,166, how much is accounted for by putting a C in the 256 place. To figure this out, we have to multiply 256 times 12 because that's what C represents. So when we multiply 256 by 12, we get 3,072. So a C, hexadecimal C in the 256 place represents 3,072 decimal. So we have to figure out how much is still left of that 3,166 that we still have to represent in the other two places. So we subtract that 3,072 from 3,166, and we're left with 94. So now we look at the next place over, the 16's place. 16 is less than 94, so we know we can take at least one 16 from it, but we want to figure out how many 16s we need to take from it. So to do that, similar to what we did with the 256 place, is we divide 94 by 16. When we do that, we get 5.875. Again, we only are really concerned with the whole numbers here. And so the decimal 5 is the same as hexadecimal 5. So that's good. It's an easy conversion. So we put a 5 in the 16th place. Next, we have to figure out how much is accounted for by having 5 16s. To do that, we have to multiply 16 times 5, and that gives us 80. Just like before, we have to subtract that 80 from the 94 to see how much we have represented here. And when we do that, we are left with 14. Now we have to deal with that last 14 in the ones place. So we have to figure out how many ones are there in 14. This is probably the easiest step. There are 14 ones in the number 14. So we have to go back to our hexadecimal and decimal conversion here. So a 14 in decimal is represented as E in hexadecimal. So in the ones place, we put an E, and that accounts for the last 14 of decimal. When we subtract that out, 14 minus 14 is 0, so we know we are done with our conversion at this point. So our final conversion, 3,166 in decimal, is equivalent to C5E in hexadecimal.